Alrighty, welcome back to 105. So today, doing decision making. So again, this is supposed to be the intro programming course. So we're going to have some more practice dealing with if statements, using multiple if statements today, and general good practice for coding. So, our good practice, even if you know programming, maybe hopefully pick up something with this lecture, because well, writing a program is never quite done. It's always just continual maintenance and making sure we write readable programs. So I guarantee, even if you have experience, you probably do not write the most readable program. So we will be going into that today. So, other things that we can do that may show up in other labs is remember that characters are just encoded as ASCII values. So that means that character is just encoded into some number that we give meaning to, and specifically they're encoded into basically a byte. So we don't have to remember what value corresponds to which character. Like I don't need to know that capital A is 65. But you should know the relative ordering. So we learned last time how to do inequalities between numbers. Well, because characters get represented as numbers, you can also do inequalities between characters. It will first convert it to a number and then do the inequality based off that. But thankfully, whoever developed this encoding scheme, or how we convert it to a byte value, organized it in such a way that the inequalities make sense. So what you should know is that all of the digits, the character digits, are all in order of their digit value. So 0 is less than 1, is less than 2, etc., etc. Yeah?
So very quick thing, amazing. So can you please try to fix the streaming, because sometimes they cut out early, like 10 minutes just cut out.
Yeah, I always re-upload them.
Thanks.
So yeah, the lectures I've cut off, it's the Wi-Fi in the room, I can't deal with it. So if it ever cuts off, let me know, I'll re-upload it. I have a recording on my laptop for that scenario. All right, so yeah, here, everything, the character values are in order, so you don't need to know what the actual character numbers get representative, just know the relative ordering. There might be some characters between the capital letters and the digits, but how it's encoded is all of the capital letters are always greater than the digits. So you don't need, and there could be other characters here, so you shouldn't assume that, characters follow directly after. But all of the letters are in alphabetical order, one after the other, and they're all separated by that value 1. Then there is another gap, and then all of the lowercase values are also in alphabetical order. So the values of them are greater than uppercase, but the lowercase ones are all in a rule. So using that, we can actually start converting and arguing about what the user typed in. So we'll have an example of that today. So any problem with that, you should probably just know that it's laid out more or less logically. And the unlogical thing is that it goes digits, uppercase, and then lowercase. So you can use arithmetic with characters. So the character 0 through 9 are sequential. So all the values increase by 1. So I can actually use a bit of trickery to actually come up with other digits. So the character 0 plus 2 means I'm going to move 2 values forward. So we don't know the encoding of this. 0 will just be some number, but since we know the relative orderings, whatever this value is, in which case if you actually want to know, I believe it's the value 48 or something like that, but again, we don't have to know it. If I add 2 to it, it's whatever 0 is plus 2, so 2 characters forward, that will give me the character 2. If I try and represent as a character again, and same thing if I do 0, the character 0 plus 5, I will get the character 5. So they're laid out like that. I can do a bit of trickery with knowing the values and how they're laid out. So the characters, again, A through capital Z are sequential as well as lowercase a through lowercase z. And as another note, if you want to convert uppercase to lowercase, I could take an uppercase character and add 32 to it. That is just how the encoding works. So if I do uppercase A plus 32, that would be a lowercase a. That is just for, I don't know, fun. I have a very weird definition of fun. You don't have to remember that number 32. Just know that, again, the uppercase values are all lower than the lowercase values. So some other examples, since they're all alphabetical, if I use the character uppercase A and add 2 to it, that means I'm going to get the character that is 2 away from A, again, in order. So A plus 0 would be capital A, uppercase A plus 1 would be capital B, A plus 2 would be capital C. And then same for lowercase. If I did lowercase a plus 3, that gives me the letter D. I can also use it to go backwards as well. So if I want the letter before O, I could do the character O minus 1 to get me N. So anyone have any problems with that? Sounds fun, right? We're taking computers and, I don't know, we're looking at their internals. So one problem we might have is that, hey, maybe we want to write a program where the user can input a character and then we will say whether or not it is a letter or not. So now we know that characters get represented as bytes. We know how to do inequalities between bytes. So we should be able to determine whether or not the user has inputted a letter or not. And of course, we will be using an if statement. So right now, if 1, that means no matter what I type on the keyboard, so this program just asks me to input a character no matter what I type, because it says if 1, it's always going to print you entered a letter, which sometimes works. So if I run this program called isLetter, actually I should probably compile it just to make sure. If I run this program called isLetter and I just type a G or something like that, it says you entered a letter, but it's like the broken clock theory, right? A broken clock is right twice a day. Well, it turns out my program is right for any letter I type in because it always prints it's a letter. So if I type something like 6, it will also print you entered a letter. That is not good. So I want it to say whenever I enter something that is not a letter, I want to say you have not entered a letter. So with what I just showed you and knowing if statements and all the operators before, can anyone tell me what to write in this if statement such that this only prints if I enter a letter? Anyone have a think? Give me a help. Yeah?
So, like, whether the character is attributed to aspects, or like, I don't know, do you want lowercase or uppercase?
So, yeah, I want this to print I entered a letter for uppercase or lowercase.
So, like, maybe C should be less than or, so greater than or equal to greater case A, and less than or equal to lowercase a.
Okay, so first solution that we will go with is C. So to know that I have a letter, since I know all of the capital values are lower than the uppercase values, maybe I want to make sure that the character I enter, so C, is greater than or equal to capital A, right? And well, that's not sufficient because I could enter something greater than a lowercase z. So maybe I add in another condition. So one way we might think about this in, like, I don't know, in normal math, we would probably write something like this, right? Make sure that C is less than or equal to A and something like that, right? So make sure that C is between capital A and lowercase z. So that's how we would normally write it in math, right? Well, can't do that in C. So it turns out here it says the result of the comparison is the constant 122 with a Boolean is always true. So what's that trying to tell us? Well, remember all of the rules of C. So in this case, the less than or equal to is a binary operator. So how C is going to evaluate this is if I add parentheses around it, it will first do this. So A is less than or equal to C. And then it will take the result of that and do is less than or equal to lowercase z. So in this case, this will return a Boolean, right? It will say either yes or no. So it will return either a 1 or a 0. And then a 1 or a 0 is always going to be less than or equal to z. So this is always going to be true, which is what the compiler is trying to tell me. So because that's how the binary operators works, if I want both of these things to be true, so that's usually what math means, I have to do that AND operator. So I have to actually rewrite it so that I have to make sure C is greater than or equal to A and C is less than or equal to negative C, or lowercase z. And sorry, I missed a bracket. Where you can put. So something like that. So everyone okay with that as our answer? Anyone have any problems with that? Yeah. Yeah, isn't there a jump between the uppercase and the lowercase? So remember, on the slide, I intentionally put just non-relative ordering between capital Z and lowercase a, meaning there could be other characters in the middle of it. So I shouldn't just assume that lowercase a follows uppercase Z. And why is that? So we can come up with examples. So it turns out if I compile this program and run it, if you don't know what values fall in between that, you might think your program actually works. So is letter, maybe I enter, I don't know, a J, capital J, it says you entered a letter. Great, run it again. I enter a 6, it says you did not enter a letter. Seems to work. I can enter, I don't know, just a lowercase z. You entered a letter. All great. So, turns out if I was, I don't know, trying to really test your program in some way that has like hidden test cases or something like that, something you may not consider ahead of time is, well, what about an underscore? Is an underscore a letter? No one would probably say an underscore is a letter, right? So if I run this, you entered a letter. Uh-oh. So turns out underscore is one of those characters that gets represented between uppercase Z and lowercase a. So if I want to rewrite my program to actually handle that case, how would I rewrite it that handles, you know, handles that case where it wouldn't say that underscore is a letter? Yeah. C is not equal to what?
We're testing that C should not be
We could put in, yeah, we could put in like, just add another and condition here. So C does not equal an underscore. So that is one way to do it, because if I do it now, it says you did not enter a letter. But that works for this case, but is not a very prudent solution. This only works if underscore is the only thing between that, right? So unless I want to go through every single character that's between them and rule it out, probably not a good idea, because I can come up with another character that is, you know, between that. So the character caret, the little hat thing, is that it? Is that a letter? Well, probably not, right? But if I run it, it says you entered a letter. So I don't want to exhaustively go through all of them. So any other suggestions how I would solve this? Yeah?
C is greater than or equal to capital A, and C is less than or equal to capital Z. And then you do the OR operator, and then you do the same thing, that C is greater than or equal to lowercase a, and C is less than or equal to lowercase c.
Yeah. Okay, so just to repeat what she said and try and break down the logic, we're trying to test basically if the character is a uppercase character or it's a lowercase character, right? So we know between capital A and Z, There's nothing in between, all sequential. Same with the lower cases. So if I want to do this properly, I have to check if the letter you enter is an uppercase or a lowercase. So what we had before, if I change it to just a lowercase z, that makes sure we have an uppercase character, right? To finish it off, I might have to do something like or C is greater than or equal to lowercase a, and C is less than or equal to lowercase z. So if I do this, my compiler is kind of complaining. It says, and within a or is, where does it say that? Yeah, and within an or, probably not a great idea, because remember the order of operations and the precedence rules. If we didn't remember the precedence rules, we don't know whether or not this, maybe this happens first, then this, or maybe, you know, it groups them all to the left. Maybe they're at different precedence levels. Who knows how this actually gets interpreted? So the compiler's telling us, since we're mixing operators, I may as well add parentheses to make sure what I think happens first actually happens first. So if I wanted to break this up, I want to make sure this happens in brackets first. So I want to check basically first if the character is an uppercase character or it's a lowercase character. So I could put brackets around checking if it's an uppercase character, and then brackets around checking if it's a lowercase character. So that makes my compiler happy, and that seems to be a bit better. So anyone disagree with that? All right, so if I run this now, you know, capital A says it's a letter, lowercase j, it's a letter, 6, not a letter. Let's see, caret, not a letter. Seems to actually work now. So, everyone okay with this program? Any improvements we could make to it? So, if you came back to this a week later, would you remember everything going on there? Would it be hard to read? Or should I, you know, maybe explain why I'm doing something or write code that's a bit more clear? Yeah. Yeah, I could write comments. The comment should explain why. So it'd be like, yeah, first I'm checking if it's an uppercase or then a lowercase. Or for most things, for something simple like this, if I just restructure my code and use variables and give it a name, generally I'll make my code a lot more readable. So as a general rule of thumb, if I have multiple brackets and stuff in my if statement, I should probably try and break it down to different parts so it's a bit more readable. So this if statement, I can actually describe to you what this is supposed to be, right? I've said it a few times. What is that highlighted if statement supposed to be checking? Yeah. Yeah, if it's an uppercase character, right? So instead of that, why don't I just, the result of that is a Boolean. We know Booleans exist. So why don't I just create a Boolean called just is uppercase? And then I can just move this into there, and I can get rid of the bracket. Since I don't need it, it's by itself now. And then instead of having that big ugly thing, I could just write is uppercase. And then similarly, for the other side, I can rewrite it so I can get rid of the brackets. The other side is I'm basically checking if it's lowercase, right? So I can take this, get rid of this, and it also handily dandily gives me a way to get rid of the brackets. It is lowercase. So is that a lot more readable now? Probably, right? That's so clear, I don't even need a comment. Maybe I need a comment to explain, you know, the relative values of ASCII characters. That's fine, that describes why. But I don't need a comment that says, like, check if it's an uppercase. It should be clear that I'm checking that it's an uppercase from just renaming my stuff in code. So it's going to be functionally equivalent. The compiler doesn't care that you created new variables. It will get rid of them if it doesn't need them. So it won't make your program any less efficient, but it will make it a lot more readable for you. So now if you come back to this in a week, you can probably have a snowball's chance in hell of actually reading it again and understanding what is supposed to be going on, even without a comment. So, any question about that? Yeah?
It's kind of unrelated, but you define C as /0. Is that like the null for C? Like,
Yeah.
when you print it, will it like just stop
Yeah.
after that character? Like, you hadn't changed it?
Yeah, so when I initialize C, that is, so if it was at the beginning of a string, we don't know what string is, it will not print anything. If we just use this character, it will print out the byte 0. So we can actually use the byte 0. We'll get into that a bit later though. But yeah, this is just a character representation of 0. If I do this, means the same thing. It's just a way I initialize it. All right, so any questions about that? Cool, we wrote a nicer program. So here's, again, just on the slide so you have it, here's what we started with, and here's what we ended with, which is a nicer way to write it. Basically, if you see you have brackets within brackets, you should probably strive to give names to things and rewrite it in such a way, especially when you're beginning, that you don't have any brackets anymore, because it just makes it a lot harder to read. So try and write programs like this. Again, when you write programs, typically there's the first program you write, which solves the problem, but looks ugly, and then you go back to it. That's what normally happens with programmers. You go back to it and you try and write it better so that it is a lot more clear to you. So even with lab 1, wait like a week, go back, try and read your lab 1. You'll probably be like, well, except for part 1, probably be like, oh, I can rewrite this in a way that makes it a bit more clear. So can start that practice even now. All right, and just to be clear, so the compiler optimizes those logic operators like OR. So if I write something like some complicated condition or some complicated condition, another complicated condition, if the result of this evaluates to true, so it runs this and decides, hey, this is true, the compiler has something called a short circuit, so it will not evaluate or try and compute this condition, because if this is true, it doesn't matter what the value of this is, the whole thing is going to be true, right? For an OR, as long as one of them is true, it doesn't matter what the other one is, the whole expression is true. So your computer won't even run what happens in here. It won't even bother trying to compute it. It will just straight up skip it. And then, again, that's because if the left-hand side is true, the final result is true. So the value of the right-hand side doesn't matter. Yeah?
So in this case, wouldn't that make this more efficient than using 2 booleans?
Yeah, so in this case, if we go back here, technically I'm evaluating both Booleans here, so this is technically a little bit more inefficient, but computers are very, very fast. This is something silly, and the compiler can still rewrite it in a way that the other thing is also true. So there's a common expression with computer scientists that says premature optimization is the root of all evil, and that would be an example of it, because I'm trying to outsmart myself and I'm trying to make my program go faster in a way that hurts kind of the readability of it. So until you know what actually matters, strive to write readable programs above all else, especially when you start, because if you look at it and you go, what the hell is this? Then, well, probably not that great, right? All right. So the flip side is also true. The compiler also optimizes that AND logic operator. So if I do the same thing, I write some complicated condition 1 and some complicated condition 2, then in the case that the left-hand side evaluates to false, the compiler, again, will not evaluate the right-hand side, because it doesn't matter, right? If the left-hand side is false, the whole thing has to be false, because an AND can only be true if both sides are true. So another way to call this is, it's called lazy evaluation. So the compiler is very lazy. C is very lazy. So if it doesn't need to calculate something, it will not bother. But again, this is a compiler optimization. You don't really have to know about it. It won't be tested. It's just a good thing to know. And if you write very complicated code, you might get hit by this a little bit. So again, since the left-hand side of the and is false, the result must be false no matter what. So the value of the right-hand side doesn't matter, so why bother? All right, another thing we can do is, you'll cover this more in a future course, in your architecture course, but we can rewrite logic statements using something called De Morgan's laws. So it's a set, it's like just rules of what kind of if statements are equivalent. So the laws state that not A or B, all in brackets. So remember with the unary operators that that precedence comes first. So A or B and then not, so the flip value of all that is the exact same as not A and not B. Also not brackets A and B is the same as not A or not B. So these two lines, well, the left-hand side is equivalent to the right-hand side in both of these lines. So if I wanted to only check for the character not being a letter, maybe I use something like I just try not the letter expression I had before. So I would not brackets is uppercase letter or lowercase letter. So I'm making sure it's not a letter. So just nodding that expression. I could rewrite this if I wanted to, which is exactly equivalent as just, if I'm checking that it's not a letter, it's not an uppercase letter and not a lowercase character, which means overall it is not a letter. So both these things are equivalent. Again, whatever you prefer, in this case, it's simple enough, whatever you prefer is easier, but if you have nested expressions, it might be easier to flip one on its head. Again, doesn't really matter. So the only thing to do is beware and use brackets to get what you mean. So if I just remove the brackets from not is uppercase letter or lowercase letter, and instead I just wrote not uppercase letter or lowercase letter, these two expressions are not equivalent, right? Because the unary operator always happens first if there's no brackets or anything like that. So what that will do is not this, so it will only be true if it is not an uppercase character, and then this whole expression is true if it's not an uppercase character or it's a lowercase character, which is probably not what I mean and will get me into all sorts of trouble. So if I wanted to be explicit about it, knowing all the precedence rules, which again is why I say you should probably use brackets if you don't want to remember them, this example is exactly the same as if I put brackets around this not uppercase letter, because all the unary operators have a higher precedence, aka they're done first, kind of like exponents, than anything else. So this will be evaluated as not uppercase letter or lowercase letter. So again, you don't have to remember the relative precedence of binary operators, unary operators, everything like that, or between each other. Just know unary operators have a higher precedence, binary operators are lower than that, and aside from that, you should probably use brackets just to make sure the compiler does what you mean and there's no surprises. Okay, also, just as a beware thing, so I guarantee you might come into something like this. So let's say I just want to print it if I enter a letter and that's it. I only just want an if statement and I don't want else. So if I do this, right, if I enter a letter, it should still tell me that I entered a letter. That was a G. And if I enter 7, it doesn't say I entered a letter, right? It just doesn't print anything. So one thing you might encounter, which will be a fun thing to debug, is maybe you're getting a bit too happy with semicolons and just getting used to putting semicolons everywhere. So if I accidentally make a typo and do something like this, anyone guess what will happen? Yeah.
So like if the
If the value is uppercase, it will still run. Like, if it's uppercase, I do want to say I entered a letter, right? Yeah. Sorry? Yeah, it just skips and prints every single time. So let's test that. So if I do something like that and accidentally do that, well, I get a warning from my compiler, so you should strive to have no warnings from your compilers because the compiler is written by very smart people. If it gives you a warning, it should start setting off alarm bells. So this says here, if statement has empty body, so that might not mean much right now, but remember the syntax or rules in if is like if expression and then some statement. Turns out that by itself the semicolon is a statement, and it is a statement that does nothing. So it's a perfectly valid statement, but it doesn't do anything. So in the case that this is true, it will do nothing. And then the curly brackets are just a way to structure your code. They don't actually run or do anything like that. So it would be the same thing as if I just wrote this. Doesn't really matter. And it means that this will just print every single time, in which case, like, it's just a way to group statements together, the curly brackets. In this case, since I only have one statement inside my curly brackets, it's the same as if I just wrote this. So it's the same as if I just wrote this, and it should just printf every single time. So let's rewind, and let's just see. So compile it again, is letter. Again, if I type a letter, it's going to look like it works, but turns out if I try and test it with digits or something like that, it will always print you entered a letter no matter what. So if I put in 7 again, it says you entered a letter, which of course is not what we expected. So that is one error you might have a very hard time debugging. So beware that a semicolon by itself is a statement, and it is a statement that does nothing. So that means in this case, if this is true, and I put one of the first very confusing things that may happen to you. So I'm just including it in here so you're not caught off guard by it. And I like seeing errors you might run into to save yourself like a good hour debugging or something like that. Because if you didn't know this, you might just, eventually give up after a few hours and then rewrite your program. All right, so again, semicolon by itself. Oh, yeah. Sorry? So semicolon, like usually it's like, usually I do like printf and then a semicolon, right? And that's one statement, and that one statement calls that function. But if I just do a semicolon by itself with nothing before that, that's also a statement, but there's nothing to the left of it, right? So it doesn't do anything. So that's what I mean by it's an empty statement. It's a statement, but it doesn't do anything. That's just the rules. So yeah, so again, just a semicolon by itself is an empty statement that does nothing. And again, when the condition is true here, it does nothing, doesn't help. No matter what, it runs the printf code, or it just jumps directly to it if that thing is false. Alrighty, so had this question last time, so we can chain if statements together. So I could write something like, some code before it, and then if A, and then curly brackets, and then say this code should only run if A is true. If A is false, and I put an else here, it will fall here, and then an if is another valid statement. So it will then check if B is true, and if B is true, this code will statement. So I'm checking the value of A. If A evaluates to true, I go and execute that code in the if statement, so all of that A code. And when I'm done executing those statements, I go to the end. Otherwise, if A is false, then I check B. If B is true, I execute the statements in B and then go to the end. Or if B is false, I just go directly to the end. So now I have a whole bunch of different ways. I now have 3 paths through this, right? So questions about that? That's how I can chain together if-else statements. So if you're from Python and you know an elif, I can functionally do the same thing in C. It just looks a bit uglier. But it turns out to be the exact same thing. All right, so I can also write nested if statements. So if I write something like if A and then if B, I can put an if statement inside an if statement. So putting an if something inside another one, we call that nesting. And each time we begin an if, we add another level of indentation. So it's to say whether or not, at a glance, whether or not a statement is included in another one or not. So when we add another level indentation, that's just skipping over 4 spaces. So this would be a level of indentation. This would be another level of indentation. So I can nest them together. So this code will only run, in this case, if both A and B is true. So because of that, if I look at my code and I don't have anything, that runs whether B is true or not true, then again, those statements only run if both A and B is true. So if I'm trying to write cleaner code, I should write something like this instead. I should just not nest if statements if I don't have to, and just write A and B instead. So in general, the fewer level of indentations you have, the easier it is to read. So if you can eliminate one, you are writing a clearer and better program. So speaking of that, let's go into our last example of the day. So I will need help with this. So we are going to write a program where the user enters 3 numbers, and we want to output the largest number that the user has entered. And it is okay if our first version of this is a bit ugly. We will refine it and see if there's ways to make it better. So right now, I just say enter 3 integers. I define all of them on the same line using a comma, which I recommended against, but I'm doing it so it fits on a slide or fits on the screen. Then I scan F, ask the user to input 3 integers, and then I want to display the maximum of it. So right now, since I don't initialize max, I'm going to get some big random value. So anyone want to help me write this program so it should always output the largest of the numbers I have inputted? Yeah. Yep. So starting point, if x is greater than y. Yep. If x is greater than max is equal to x. All right, so let's follow the flow of this real quick. What's the warning here? Variable max is not initialized. Yeah, that's fine. All right, so to follow the flow of this, just so everyone's on the same page, first we're checking if x is greater than y. So if x is greater than y, then we know the maximum value is either x or z, right? So then we're trying to distinguish which one is which, right? So this will, if x is also greater than z, then the max is equal to x. So everyone agree with that? If all those things are true, then x is the maximum value. Yeah?
You can also use the max function to get rid of this.
We're assuming we don't have the max function. We're assuming we're writing the max function. All right, what else should I write here? Yeah?
After line 13, you can do an else.
Yeah, so I should have an else here. Yeah, so in this case, that first if there checks of these two, if I know that max is x or z, and this is the case where I know the max is x, well, the opposite should be true, right? If the max is not x, the max has to be z. So it has to be something like that, right? All right. Yeah.
Right outside that if
Yep.
statement, we can just write else max is equal to y. But I don't know, like,
Else what, sorry?
else max is equal to y.
Max is equal to y?
And we can
So, can I make this assumption? Else max is equal to y. No, why? Yeah, so just to repeat what he said, so if x is greater than y, or if x is not greater than y, that means y is bigger than x, right? Doesn't mean, what's it relative to z? I don't know, so if I do this, we could do max of 3. Let's say input x, y, and z. So if I do that, yikes. Did I compile it? 1, 2, 3. There we go. Now it says my maximum is 2. I forgot to compile it again. Another common issue in C. So this says my maximum is 2, which is definitely not true, right? Yeah. Yeah, I could make that same idea. Oh, yeah? Sorry? Well, if it's the same number, then I don't care which one it is, right? I don't care which 2. If it's like 1, 2, 2, if I say 2, that's fine. All right, so you said else if, maybe I want to check if, what do I want to check? If y is greater than z. So if y is greater than z, what do we know? Yeah. Then y is greater than both x and z. So, yeah, so in this case, y is greater than both x and z, so the max is just y, right? Yeah.
You could also set the max equal to z initially. And then
Yeah. Yeah, so I could also set the max initial to z initially. We'll go into that in a second because that's one of the cleaner things we'll do. So if I didn't want to do that, another equivalent thing I could do is just put in an else here. And the last case to cover is just the max is equal to z, right? Everyone okay with that? So let's do some quick tests to make sure it works. Whoops. Let's call it max of 3. So if I do that, appears to work, right? Let's do it in a different order. Maximum is still 3. 3, 2, 1. Maximum is still 3. So it appears to work, yeah? If it's not greater than, so 3, 3, 3. Yeah, 3, 3, 3 is okay. What about 1, 3, 3? Fine. 3, 1, 3? Fine. 3, 3, 1? Whoops. Sorry. 3, 1, 3. All good. So, this looks a little bit ugly. So if we come back to this, I put a comment that says, the max is x or y. Then I got lazy about it and didn't write a comment here. And I've nested if expressions and everything like that. So one way I could rewrite this to be a little clearer is, and I have different examples in the slides, but if I just skip it, an easy way to kind of argue about this is maybe I just want to come up with a single condition where x is my max and then or y is my max. So in terms of what single if condition would mean that x is my max, well, again, these were kind of nested together, right? I had an if nested within an if, which is the same thing as just doing an and. So maybe if I want to really make sure, I can do x is greater than or equal to y, and x is greater than or equal to z. And that looks a lot clearer to me that my max would be x in that case, right? And then I could also do else if, and then the same thing. If y is my greatest one, it means y is greater than or equal to x, and and y is greater than or equal to z. and that means my max would be y. And then I could either do just else max is equal to z, so if none of the other things are true, they're either all the same or z is my max. But I could also just get rid of this else and initialize max equal to z at the beginning, and that also saves me a line. So I could just do something like that to make my program a lot shorter. So I just take a guess, say max is equal to z, I just guess that z is the biggest value, and then if y is the greater, or x is the greatest value, which is only true if those two things are true, I can set max equal to x. Otherwise, if I know y is definitely the biggest thing, I can set max equal to y. And I would argue that this is probably more readable than trying to nest if statements together. But when you're developing it, it's good that you start off with nested if statements. But after you kind of get it working, just try and think about it again and see if you can rewrite it so that it's a bit more clear. So we can end there. So